Hello friends, welcome to Study Spectrum. Myself Amreen Rawat and I am going to start with the very first chapter of 11th standard state board that is kinematics. Kinematics will study about mechanics, which is a branch of physics, and it deals with the motion of the particle in different directions. So here we will start with the path travelled by a particle. The path travelled by the particle is known as distance. It can be given as x because it moves in the x direction. Moreover, if suppose a person is moving in a circular motion, the total distance travelled will be the path length. If we explain it, suppose if there is a person moving in different directions to reach a specific destination, distance will be the total path length whatever covered by the person to reach the destination. Whereas if we talk about displacement, we will just draw a straight line from the initial point of the object to the destination point. This distance is called as displacement. If we are supposed to define this term, we will define it as the distance travelled by an object from the initial point to the final point. So it is the shortest distance, whereas distance is the total path covered. Next is speed. If we talk about speed of a particle is the distance covered by the particle in the interval of time. We give it as speed as distance upon time. Whereas velocity of the particle is displacement of the particle covered by the object. It is also denoted in the same way. Speed of the particle is defined as the distance travelled by the particle in a particular time. Whereas if we define velocity is the displacement in the particular interval of time. We denote it as x bar upon t. This bar is because displacement talks about direction and velocity also speaks about direction, which means it is a vector quantity. Whereas speed, there is no direction. The only difference between speed and velocity is speed is not concerned with the direction, whereas velocity is concerned with the direction. So we can say that speed is a scalar quantity and displacement, velocity, is the vector quantity. Now the next part of the topic is acceleration. As we are talking about speed and velocity, the change in the speed or velocity of the object is called as acceleration. So in terms of this diagram which we have already drawn, we can say if the particle is moving from here to here, his initial velocity was 30 meter per second. Then he changes the velocity to 40 meter per second. Then it goes to 50 meter per second. Here the change in the velocity is 10 meter per second square, which is our acceleration part. This is known as acceleration, the change in velocity. Acceleration is also a vector quantity. The unit of measurement for acceleration is meter per second square. In the acceleration we also talk about average velocity. Average velocity is the total velocity, is the sum of all the velocities taken with respect to the time. Suppose we have to find the average velocity. So average velocity will be given as the sum of all the velocities in a motion upon the total time taken. If suppose the time taken for the object to move from the final to the from the initial to the final point is 5 minutes, 90 upon 5, which is equal to is the average velocity of the object. In this way we find the average velocity. The next part in the velocity is the instantaneous velocity. The instantaneous velocity is the velocity of an object at any instant of time. Suppose we are asked to determine the velocity of an object in this motion. This is a motion of an object, this is displacement and time graph. Instantaneous velocity of the object at any instant of time, suppose say 2 seconds. So whatever the corresponding displacement at the point of corresponding to the 2 second is called the instantaneous velocity of that object. Similarly, in acceleration also we can find instantaneous acceleration, that we will discuss it later. Now we will go to the graph part. How to find different values of velocity, speed, distance and acceleration using the graphs. The very first graph we take of distance and time. In this graph, the very first graph that we will discuss is distance and time graph. In this graph, if we plot the motion of an object with constant velocity, that is no change in the distance of the velocity, the object is stationary. In this case, what will happen? For a stationary object at any particular distance, the time keeps on changing and the object remains at the same position. In this case, the graph that we will find is a straight line parallel to the x-axis. This is time axis, this is distance. So we are getting a straight line parallel to the x-axis in this case for a stationary object. Second case, we can see object moving with constant velocity. Again, we will plot a graph of distance and time. If the object is moving equal distance in equal interval of time, such an object will give us a graph which will be a straight line with a slope. And from this graph, velocity of the particle can be determined by finding the slope of the graph. Using the formula of slope, y2 minus y1 upon x2 minus x1. Taking any 2 points on the slope, on the line, finding the slope of the line. In this way we can find the velocity in case of distance and displacement. This was the case, these were the two cases that we have seen. Now further we will go on velocity and time graph. Now the third graph that we will discuss is about particle moving with variable velocity. That means if we plot a graph of particle moving with variable velocity, a graph of displacement versus time, we will get a slope. It can be anywhere, it can go anyhow. This is increasing slope, it may be a decreasing slope. We can find the velocity from this graph by drawing a tangent to the slope at any given point, such a velocity is called instantaneous velocity. After drawing the tangent to the slope, we find the slope of the tangent. So velocity is equal to slope of the tangent in case of variable velocity. Same here, the same thing we can do here. If suppose time instant is given, we just go above that, draw a tangent to the slope and find the slope of the tangent. So in this case also we will find the velocity with respect to time. So next graph we have velocity and time graph. Even in this case we have three different set of graphs. The very first case that we will see will be constant velocity. An object moving with constant velocity. In this case, if we plot a graph of velocity versus time, we will obtain a straight line parallel to the x-axis. As same as the stationary that we did in the last time, the same graph we will obtain for velocity versus time in case of constant velocity, because the velocity of the object is varying at a constant rate. So here we can find the distance as well as acceleration. How to find the distance? To find the distance we just have to draw a straight line perpendicular to the time axis by finding the area of the area under the line. We can find the displacement of the particle. So displacement of the particle can be given as area of rectangle, say OABC. Now the next case that we're going to see is constant acceleration. In this case, if we plot a graph of velocity versus time again, and the acceleration is constant, that means velocity is changing at a constant rate. In that case, we will get a straight line with a slope. And from this graph, we can obtain acceleration as well as displacement. Acceleration we can find by finding the slope of the graph. Whereas to find the displacement, we will just draw a straight line parallel perpendicular to the x-axis, and we will find the area under the slope. That will be displacement equal to area of triangle OAB. That will give us the total displacement by the particle. Now the third and the last graph that we will see is variable acceleration. in this case, if we plot a graph of velocity versus time, we will obtain curve. This curve is the increasing curve. We may also obtain a decreasing curve. So from this graph we can obtain again acceleration as well as displacement. Acceleration we will find as same as how we found the velocity part, by finding the by drawing a tangent to the point wherever we have to find the acceleration and finding the slope of the tangent. Such acceleration at any instant of time is called as instantaneous acceleration of the particle. So acceleration is equal to slope of tangent. We can also find, as I said, the displacement in this case. The displacement. Suppose the curve is closing. Suppose the curve is closing. How to find the displacement? It is not a regular object to find the displacement by taking the area like we did in the last things, rectangle and triangle. Here it is an irregular object. So how to find it? Obviously we are drawing this on a graph page, and graph page consists of some blocks. Displacement will be equal to the number of boxes and whatever the first reading or the first value that we have decided for velocity, the scale. So it is equal to, displacement is equal to number of boxes multiplied by velocity. This is how we will find displacement in case of irregular curves. Now moving to the further part of the topic, which is our projectile motion. Now what is projectile motion? Any object which is thrown in the forward direction, it goes in the upward direction and it again comes back to the ground because of gravity. Such a motion is called projectile motion. Suppose an object is thrown from zero position, it follows a curved path and it again comes back to the ground. Such a motion is called as projectile motion. In this, the total distance covered by the object is called range of projectile. The maximum height attained by the projectile is called maximum height and denoted as h. Here in the projectile motion, the time taken by the projectile to complete one trajectory is called as time of flight. Now what is trajectory? Trajectory is the motion of projectile. The total path covered by the projectile is called as trajectory. And the velocity at which it moves is called as the velocity of projectile. The angle at which it is thrown, the angle is called angle of projection. This is all about projectile motion. Let's further move to the derivation part, how to derive the projectile motion. At very first, we will recall the kinematic equations. First kinematic equation B is equal to U plus AT. The second kinematic equation is S is equal to UT plus half AT squared. And the third kinematic equation is V square is equal to U square plus 2 AS. these are the three kinematic equations that we have already studied. Now from these three kinematic equations, we will use these three kinematic equations to find the path of projectile, range of projectile, time of flight, and the maximum height that can be attained by the projectile. Suppose we consider a projectile motion starting from 0. The y component, we resolve the velocity of projectile in two components, which is y sine theta and u cos theta. These are the velocities which we have resolved into two components, u sine theta and u cos theta. The projectile moves in the upward direction. At a particular level, it reaches, and here the velocity of the projectile becomes 0. This is where it attains the maximum height and it comes back to the ground with the gravitational pull. Here if we see, as it is going in the anti-gravity direction, we take the acceleration as -g in the upward y direction. So the motion of projectile in the y direction we consider as 0. Now we recall the very second kinematic equation, that is S is equal to ut plus half at square. From here if we see the direction, the distance covered by the projectile that we are considering as x is equal to Vt, which is the standard definition given by the mechanics part. X is equal to Vt, so x is equal to V, here we have u cos theta into t. Therefore, we can say that t is equal to x upon u cos theta. This is the value of t that we have found. So we have t, we have a, which is equal to -g, we have initial velocity, that is u sine theta. Now from this equation, we will substitute these values that we have already derived in this equation. S is equal to y equals to u, which is the initial velocity that we take as u sine theta. T we have already found, that is x upon u cos theta plus half, a is -g as it is going in the opposite direction to the gravitation. T again we can substitute as x upon u cos theta the whole square. Now y is equal to, u gets cancelled, sine upon cos giving us tan theta x plus, instead of plus we can take this minus outside, minus half g x square upon u square cos square theta. This is the equation that we obtained from substituting the values in the second kinematic equation. From this equation, we can prove that this equation is equal to the standard equation of parabola. So, what we can do, tan theta is equal to alpha and g upon u square cos squared theta is equal to beta. So y becomes equal to alpha x minus beta x square. Now this is a standard equation of parabola. Hence we can say that any projectile is covering a parabolic path during its trajectory. So we write y equals to u sine theta t minus g t square. From here, y is equal to 0 as we have already derived. U sine theta will remain the same, and instead of small t, we replace it by capital T, which is our time of flight, t square. Dividing the whole term by t, we will get 0 is equal to u sine theta minus gt. Therefore, t is equal to, this is half gt. T is equal to 2 times sine theta upon g. Now from this we can also find time descent, which is the time of the projectile to start from the highest point to the ground level. Time descent, time of flight is equal to time ascent plus time descent. Therefore, time descent will be equal to time of flight minus time ascent. That we can write it as 2 sine theta upon g minus u sine theta upon g. Therefore, time descent is equal to u sine theta upon g. Hence, we can also conclude that time ascent is equal to time descent. The next part that we are deriving is the range of projectile. Range, as we defined, it is the distance covered by the projectile from the initial point to the final point. So how we will derive it? We will take the very first equation that we had already derived in the first part of the derivation, that was tan theta x minus g x square upon 2 u square cos square theta. We will replace x by r and y as 0. So we will get tan theta r minus g r square upon 2 u square cos square theta. If we split tan theta as sin theta upon cos theta r minus g r square upon 2 u square cos square theta, cancelling r, we obtain, now we do the simplification, sin theta into 2 u square cos square theta upon g cos theta, which is equal to r. Here cos theta gets cancelled. We obtain u 2 cos theta sin theta upon g, which is equal to r. From the basic formula of trigonometry, we say that 2 cos theta sin theta is equal to sin 2 theta. we will just replace the term by sine 2 theta. Therefore, r is equal to u square sine 2 theta upon g. This is our range of projectile. So let us see how we derive this equation again. Starting from the equation that we had already derived from the first derivation that we did in the projectile itself, that was y tan theta x minus gx square 2u square cos square theta. This we had already derived. We are just substituting some values. Instead of this x, we substitute r, capital R, which is the range of the projectile. Y is equal to 0, that we know. After substitution of these values, we do the simplification. How we do we just split tan theta into sin theta and cos theta. We bring all the term at one side and r at one side. Doing this, we get a simplified value of the range of projectile as u square sine 2 theta upon g, where g is the gravitational field. The formula that we derived for the range of projectile was r is equal to u square sine 2 theta upon g, where theta is the angle of projection. Here, to find the maximum range, at what angle, the range of the projectile depends on the angle of projection. From this equation we can say that. So, to find the maximum range of the projectile, we will just change the angle. If suppose the angle theta is equal to 45 degrees, then the range will be u square sine 2 of 45 divided by g, which is u square sine 90 upon g. Now sine 90 is equal to 1. Therefore, r is equal to u square upon g. This r, we can say it as r max, which is the maximum range. So, from this we can conclude that at 45 degree, at an angle of 45 degree, we obtain the maximum range of the projectile. Similarly, if we change the angle theta to 90 degree, suppose theta is equal to 90 degree. So r will be equal to u square sine 2 of 90 upon g, which gives us r is equal to u square sine 180 degrees upon g. Now sine 180 degrees is equal to 0. Therefore, r is equal to 0. This is the minimum range of projectile that we have obtained at 90 degree. If a projectile is thrown at 90 degree, we obtain the minimum range. Moving further to the next part of the chapter, we will derive the maximum height of the projectile, which is denoted as h. Now, to find the maximum height, we will take in consideration the third kinematic equation, that is v square is equal to u square plus 2as. Again, we do the similar kind of substitutions. S is equal to h, a is equal to minus g, u is equal to u sine theta, and V is equal to 0. 0 is equal to u square sine square theta plus 2 minus g h. Therefore, u square sine square theta is equal to 2gh. Therefore, h is equal to u square sine square theta upon 2g. This is the value of maximum height that we obtain for a projectile. So just going through it again, we started from the third kinematic equation, which was v square is equal to u square plus 2as. We did some substitutions which are already mentioned here. We just substituted s is equal to h, a is equal to minus g, u is equal to u sine theta, and v is equal to 0. After doing the substitution, we do the simplification, and hence we find the value of maximum height as u square sine square theta upon 2g. This is the maximum height attained by a projectile where the velocity becomes 0. Hence, from this equation, we can also say that maximum height attained by a projectile depends on the angle theta, the angle of projection, and the initial velocity of the projection. The last part of the derivation, we will find the angle of projection. The angle of projection theta is given as tan inverse of 4h by r, where r is the range, h is the height of the projectile. Similarly, if a projectile is projected at an angle pi by 2 minus theta, what range we will obtain? So r dash, suppose we take that range as r dash will be equal to u square sine 2 of pi by 2 minus theta. R dash will be equal to u square, 2 getting cancelled, sine of, we just remove the 2 theta. Therefore, R dash equal to u square sine 2 theta by g, which is equal to the range of projection in the initial stage. Hence, we can say that both the range of projections r dash and r are equal.